before we actually approach the question, I just want to jog your memories. When you first learn about quadratic equations and how to solve them, okay, we develop 3 methods for solving such equations, for working with them, okay? The first kind, because when we introduce you, we sort of ease you in and we give you nice, neat quadratics which all have pretty numbers. What's the first way of solving an equation like this? Starts with an F. Factorizing, thank you, okay? We give you nice, neat stuff like this. And we say, think of the pair of numbers that adds up to 5, multiplies to 6, and then off you go. Everything's nice and neat. And then, of course, if that were an equation and it was equal to 0, then you can get the roots of that equation, the solutions to it, just by reading off the negatives, okay? After factorizing, we learn there's a whole variety of quadratic equations that don't have these nice, friendly numbers, okay? And that's where we pull in this, right? That's when we get to completing the square. What kinds of solutions are we looking for that completing the square can get, that factorizing cannot? Yeah, good. We're looking for solutions that involve surds, okay? Because unless, I don't usually think, oh yes, root 2 and root 5 will work perfectly for this, okay? We don't usually think in terms of surds, so completing the square is the method we use to do that. Now, that was then our stepping stone to develop the last technique, the most sophisticated one, which was? The quadratic. Thank you, the formula, right? Now, hopefully you remember that what you can do is take the general quadratic equation. You can take this, okay? And then you divide through by a in order to make it monic, so the leading coefficient is 1, and then you complete the square. And when you go from this and complete the square, that's what the formula is. That's where all that minus b plus or minus etc. comes from, okay? So now I pose the question to all of you. If there's been this sort of natural progression from here to here and then here to here, right? Why are we going back? What's the point? If we've advanced past this kind of thing, and really completing the square was kind of just a bridge to get to the quadratic formula, why are we bothering devoting time to it now? Any thoughts?
Does it help with finding other things?
Okay, so a reasonable kind of guess would be, well, maybe it'll be useful for stuff other than finding the quadratic formula. Does anyone know what else it might be useful for? Yeah.
Vertex.
Okay, number one, even if you take something like this, x squared plus 5x plus 6 equals 0, okay? We know we can all factorize and solve this, it's not that hard, okay? But I can still actually do complete the square on this, right? And so you'll get, something squared plus something else, right? After you complete the square, right? Well, this gives you an axis of symmetry by which you can work out the vertex, and that's really useful, okay? So when we do parabolas and locus of the parabola, we'll develop all of this in more depth, okay? There's a simpler example that comes a bit earlier than that, which is a very familiar shape. This guy, right? Now, if I were to give you an equation of a circle, right? What kind of information do we need to describe this circle definitively?
The radius.
I need a point. I need where is the center of this circle, and I might give you coordinates like, say, I don't know, maybe that's 1, 2. Okay, and then I need one more piece of information, namely radius. Thank you. So I need this distance. Okay, maybe it's 3 or 4 or 5 or whatever. Okay, once I've got that information, let me look at this. Let's just call it 4. Okay, once I have this information, how am I going to write the equation of the circle? How am I going to do it? Think back. We'll start with the center. Right? I'm going to have x minus 1 squared plus y minus 2 all squared equals r squared, which in this case is 16. Okay, so this is all nice and neat. Okay, but usually you don't get it nice and neat. You get some unmitigated disaster like this: x squared plus y squared by some random number of x's, and some random number of y's, and some number over there, okay? So what you have to do is recognizing that this came from this, you need to disentangle it. The formula will not help you here, okay? Because you've got x's and y's and their constants all intertwined, okay? The only way to find out what this actually had come from is completing the square, okay? So that's the point of this. This is revision, but it's kind of not really. It's heading somewhere that is most definitely prelim and HSC. So with that prologue in the back of your mind, how do we complete the square? What am I going to do to this thing? Anyone give me a suggestion? Nikita?
Move the 2 over to the other side.
Okay, step 1. Get rid of the constant on the left-hand side. Okay? Step 2, the important part, the completing the square part, Rita.
You take the b term, right, and you divide it by 2, right, and you square it and you plus it to both sides.
Okay, just in case you missed that, right? Exactly right. Take the coefficient of x, which is b, that's what we would normally call it, halve it, square it. That's all you have to do. Halve it, square it. Halving it gives us 4, squaring it gives us 16. And that's what we add to both sides, okay? Hence giving us 14 over there. Happy? So that was the completing the square part. The reason why it was called completing the square is because now that's a square. I can factorize this. What is it?
X plus 4
X plus 4 all squared, right? That's equal to 14. And now I can proceed and I can solve, right? X plus 4 should be equal to?
plus minus 14.
I need to take both of the square roots, okay? And then all I need to do is isolate the x, happy times. Done, okay? So completing the square, we need to be able to do in our sleep, we need to be able to do it twice within the same equation and not get confused about what constants we're adding together.